Question 1. Which of the following best distinguishes hyperparameters from model parameters in a machine learning context? Option A. Hyperparameters are learned automatically from the training data, while model parameters are external configurations. Option B. Model parameters are set before training, while hyperparameters are learned during training. Option C. Hyperparameters are external configurations set before training, influencing the learning process. Model parameters are internal to the model and learned from data. Option D. Both hyperparameters and model parameters are learned during the training process, but hyperparameters are specific to deep learning models. The correct answer is, hyperparameters are external configurations set before training, influencing the learning process. Model parameters are internal to the model and learn from data. Here's the explanation. The overview clearly states that, unlike model parameters, such as the weights and biases in a neural network, which are learned automatically from the training data, hyperparameters are external configuration variables that are set before the training process begins. Question 2. A data scientist is performing hyperparameter tuning and wants to explore every possible combination of a defined set of hyperparameters. Which search strategy would achieve this exhaustive exploration? Option A. Random search. Option B. Bayesian optimization. Option C. Grid search. Option D. Evolutionary algorithms. The correct answer is grid search. Here's the explanation. Grid search exhaustively tries every possible combination of hyperparameters within the defined search space. Random search samples randomly, while Bayesian optimization and evolutionary algorithms use more intelligent, non-exhaustive methods. Question 3. Why is it crucial to use a separate validation set when performing hyperparameter tuning? Option A. To increase the size of the training dataset for more robust model learning. Option B. To prevent overfitting to the training data and ensure the chosen hyperparameters generalize well. Option C. To evaluate the final model's performance on completely unseen data before deployment. Option D. To simplify the hyperparameter search space by reducing the number of options. The correct answer is, quote, to prevent overfitting to the training data and ensure the chosen hyperparameters generalize well. Here's the explanation. The key features/components section states that a validation set is used exclusively to evaluate the model's performance for hyperparameter selection. This prevents overfitting to the training data and ensures that the chosen hyperparameters generalize well. Evaluating on completely unseen data is the role of the test set. Question 4. What is the fundamental purpose of data labeling in the context of supervised machine learning? Option A. To compress raw data for efficient storage in the cloud. Option B. To generate synthetic data to augment existing datasets. Option C. To provide the ground truth that machine learning algorithms learn from. Option D. To anonymize sensitive information within datasets before training. The correct answer is, quote, to provide the ground truth that machine learning algorithms learn from. Here's the explanation. Data labeling involves augmenting raw data with meaningful labels or tags, which serve as the essential ground truth that supervised machine learning algorithms require to learn patterns and make predictions. Question 5. Which component of the data labeling ecosystem is specifically designed to ensure the accuracy and consistency of labels, often involving techniques like inter-annotator agreement or review by expert annotators? Option A. Labeling tools and platforms. Option B. Data management. Option C. Workflow management. Option D. Quality control mechanisms. The correct answer is quality control mechanisms. Here's the explanation. Quality control mechanisms are processes and tools designed to ensure the accuracy and consistency of labels. This includes review by senior annotators, consensus-based labeling, and Inter-Annotator Agreement (IAA) metrics. Question 6. How does model-assisted labeling, active learning, contribute to the data labeling process? Option A. It completely automates the labeling process, eliminating the need for human annotators. Option B. It leverages machine learning models to identify and prioritize the most uncertain or informative data points for human review. Option C. It replaces the need for labeling instructions and guidelines by inferring them from raw data. Option D. It is primarily used for unsupervised learning tasks where labels are not required. The correct answer is, quote, it leverages machine learning models to identify and prioritize the most uncertain or informative data points for human review. Here's the explanation. Model-assisted labeling, often through active learning, uses a preliminary ML model to pre-label data or identify ambiguous examples that humans should prioritize for labeling, significantly reducing manual effort while maintaining accuracy. Question 7. Which of the following best describes the primary purpose of model monitoring in the MLOP's lifecycle? Option A. To ensure models are always trained on the largest possible dataset. Option B. To continuously observe and evaluate deployed ML models to ensure they remain accurate, reliable, fair, and performant over time. Option C. To solely track the computational resource utilization of ML inference endpoints. Option D. To perform A/B testing of different model versions before deployment. The correct answer is to continuously observe and evaluate deployed ML models to ensure they remain accurate, reliable, fair, and performant over time. Here's the explanation. The study material states that the primary purpose of model monitoring is to ensure that models remain accurate, reliable, fair, and performant over time, delivering consistent business value. Options A, C, and D describe related, but not the primary or sole purpose of model monitoring. Question 8. A data scientist observes that a deployed fraud detection model's accuracy has significantly dropped, even though the distribution of input features, like transaction amount, location, has remained stable. However, new types of fraudulent schemes have emerged that the model was not trained to recognize. Which type of drift is most likely occurring? Option A. Data drift. Option B. Concept drift. Option C. Resource utilization drift. Option D. Anomaly drift. The correct answer is concept drift. Here's the explanation. Concept drift refers to changes in the underlying relationship between the input features and the target variable, meaning the model's learned patterns are no longer valid, even if input data distributions haven't changed dramatically. The emergence of new fraud schemes that the model cannot recognize, despite stable input distributions, is a classic example of concept drift. Data drift would involve changes in the input feature distributions themselves. Question 9. Which component of model monitoring is specifically focused on assessing whether a model exhibits disparate performance or outcomes across different sensitive subgroups? Option A. Performance metrics tracking. Option B. Data drift detection. Option C. Bias and fairness monitoring. Option D. Explainability monitoring. The correct answer is bias and fairness monitoring. Here's the explanation. Bias and fairness monitoring is defined as continuously assessing whether the model exhibits disparate performance or outcomes across different sensitive subgroups, e.g., gender, age, ethnicity, and detecting if new biases emerge in production data. The other options focus on different aspects of model health. Thanks for watching. Please subscribe to my channel.